Hello guys, in our previous lecture we saw the different formulae used to characterize the geometrical properties of a line connecting 2 points on the Cartesian plane. Now today let's look at this single problem that encompasses both the gradient of a line, the equation of a line, and the midpoint of a line. Alright, now the question says, given the points P 3,5 and Q minus 5,7 on the Cartesian plane, such that arrow x, y is the midpoint of line PQ. Find the equation of the line that passes through arrow and perpendicular to line PQ. This question is queued from WAEC 2023. Alright. Now, let us find the midpoint of the line PQ. Given that the coordinates of P and Q are 3,5 and minus 5,7. All right, so we have P is on coordinates 3,5 and Q is on coordinates minus 5,7. So it is very clear that here our x1 is equal to 3, y1 is equal to 5, x2 is equal to minus 5, and y2 is equal to 7. So now let us find the midpoint of the line connecting P and Q. Okay, now the midpoint of line PQ is given by these are x, y, which is equal to, the formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, now this is equal to x1 is 3 plus x2 is minus 5 divided by 2, comma, y1 is 5 plus, and y2 is 7 divided by 2. Okay, now this is equal to, now 3 plus minus 5 is the same thing as 3 minus 5. And 3 minus 5 is equal to minus 2. So we have minus 2 over 2, comma, 5 plus 7 is 12 over 2. And minus 2 over 2 will give us minus 1, comma, 12 over 2 will give us 6. Okay, so this is the midpoint of the line connecting P and Q. Now, but the question says, find the equation of the line that passes through R and perpendicular to line PQ. All right, now, you know it is practically impossible to find the equation of a line without knowing the value of the gradient. Now, since there are two lines that are perpendicular, let us find the gradient of the first line. The gradient of the first line, let us call it M1, is equal to, remember that the formula says y2 minus y1 over x2 minus x1. Okay, now, and this is equal to y2 is 7 minus y1 is 5 divided by x2 is minus 5 minus x1 is 3. Okay, and this is equal to 7 minus 5 will give us 2 divided by minus 5 minus 3 will give us minus 8. And 2 over minus 8 will give us minus 1 over 4. So the gradient of the first line, M1, is equal to minus 1 over 4. But it is very important to note that when two lines are perpendicular, then the product of their gradients must be equal to minus 1. So that means that if the gradient of the first line is M1, and the gradient of the second line is MO2, then that means that MO1 times MO2 must be equal to -1. That is the rule of engagement. All right, now, since we already know the gradient of the first line as a -1/4, and we are now going to substitute here. So if MO1 times MO2 is equal to -1, that means that MO2 is equal to -1 divided by MO1. And this is equal to -1 divided by MO1 is -1/4. So we have -1/4. This minus, we cancel this minus. And our result is the reciprocal of 1/4 is equal to 4. So that means that the gradient of the second line is equal to 4. And this is the one we are going to use to find the equation of the line passing through R and perpendicular to line PQ. Okay. Now, we know very well that the equation of a line is given by gradient, that is M2 is equal to y minus y1 over x minus x1. The equation of a line connecting 2 points is obtained by equating the gradient to this very parameter. Now, M2, we already know it as 4. So we now substitute. So we have 4 is equal to y minus, now y1 is this 6 here, divided by x minus x1 is -1. Okay, now we now have 4 is equal to y minus 6 divided by x minus times minus will give us +1. Okay, now when we cross multiply, we're going to have y minus 6 is equal to 4 into x plus 1. When we expand this bracket, we're going to have y minus 6 is equal to 4 times x is 4x, and 4 times 1 is equal to 4. All right. Now, when we transfer this -6 to the right-hand side of the equation, we're going to have y is equal to 4x plus 4. This one crossing over will be +6. And y is equal to 4x plus 4 plus 6 will give us 10. And this is the equation of the line that passes through R and perpendicular to line PQ. Thank you very much for your audience. Please don't forget to share our videos and subscribe to our YouTube channel. God bless you.